over S. Okay, so S is equal to Mx divided by stress max. Okay, so where does this S come in? Okay, why do we need to have this S value? So I have uploaded this table for you, okay, on Avenue to Learn. Can you all download the table, please? Okay. So if you go to Avenue to Learn, it's on lecture 13. Let me know if it's there. Okay. Sometimes I thought I posted, but it's not there. It happened to me before. You guys know that. Yeah, I'm going to do this table squeeze. Okay. So I want you all to, I'm going to zoom in this table. Okay. So on this table, can you all see SX? Right. So this is what we are calculating. Okay, this is what we are going to determine. Okay, XX. Okay. So from here, okay, from here, let's say we have to determine our moment first, our maximum moment. Okay, so we are going to check. Okay, so the maximum moment, it can be at this point, okay, or it can be at this point. I don't know. It all depends on your loading. Okay, it all depends on your loading. Okay, so let's check. So we are going to check at point B, where X is equal to A and A is equal to 3 meters. Okay, we're going to check. So if we go back to our expression or our table, okay, we're going to check at moment at point B. Okay, so it's so moment at point B is equal to minus PA. So minus PA is 70 times 10 to the power 3. And then the A is 3. So this is equal to 210 or minus 210 times 10 to the power 3 Newton. Okay. Then we're going to check at X is equal to L over 2 or X is equal to 7.5. Right? So it's 50 divided by 2, which is equal to 7.5. Okay. So we go to our equation. Wrong week. We go to our equation. Okay. So our equation looks like this. Okay. So M at 7.5. Okay, so we just put in our numbers, right? So I think I can factor the omega. I'm going to take out the omega over 2 out. Okay, so omega over 2, right, is equal to minus x squared plus by L over 2, right, minus by LA plus by A squared over 2, and then minus PA. Okay, so I'm going to use this no, the over 2 is taken out. Okay. Okay, so x squared L, okay, the second expression have a Lx down here, minus by LA plus by A squared over 2. Okay, so minus x squared plus by Lx minus by LA plus by A squared. Okay, so now I'm going to put in the values. So omega over 2, this is 45 times 10 to the power 3. Bracket minus 7.5 squared plus by L is 15 multiplied by 7.5 minus by 15 multiplied by 3 plus by 3 squared. Okay, minus by PA. PA is P is 70 times 10 power 3. A is equal to 3. So we have to check, okay? That's why this method is so powerful, because you can change the number. There is always a possibility that, right? There's always a possibility that P over A over here, this point can have its minimum that has a bigger magnitude than the maximum value. So you have to check, okay? So you have to be really, really careful. What I mean by that, sometimes what do I mean? Depending on the variables, okay? Depending on the magnitude of the load, sometimes you can get this. You can get this, and then you can have this, and then it comes back here. You can, okay, if you change your variables, okay? So from here we check. So this will be equal to minus 7.5 squared plus by 15 times 7.5 minus by 15 times 3 plus by 9 times by 40 power 3 by 2. So this is equal to 405 times 10 to the power 3 minus by 210 times 10 to the power 3. So this is equal to 405 minus 210 is equal to, wait, there's something wrong with my calculation, minus 7.5 squared plus by 15 times by 7.5. I think I might L is 15. Oh, 15. Okay, it's correct. So minus 7.5 squared plus by 15 times by 7.5 minus 15 times 3 plus by 9 is 20 times by 45 power 3 divided by 2. 455.625. I think I punched my calculator wrongly. Okay. So it's 455.625 times 10 to the power 3 minus by 210 times 10 to the power 3. Okay. So 455.625 power 3 minus 210 power 3 is equal to 245.625. Okay. So we know that point, you're going to select this point over here. Okay, we're going to select the moment over there. Okay. So now I'm going to give you a scenario. Okay. I'm going to write on this side, or yeah, I'm going to use a new page. So we know that maximum moment is at point at x is equal to L over 2. Okay. So we're going to look at the table now. Before we look at the table, we know our moment now. Okay. I'm going to put the table over here. And we are going to use the formula. Okay, we're going to calculate S is equal to moment maximum divided by stress allowable. Right, divided by stress. And if we look at If we look at units, this is Newton meter, right? This is Newton per meter squared, right? This is also equal to meter cube. So we know our Mmax. Now our stress allowable, for example, okay? So stress allowable, we pick at 160 times 10 to the power 6 Pascal. How we know this number is material property. We look at materials handbook. Okay, we look at materials handbook. Okay, so from here we calculate. Okay, so S is equal to what? S is equal to Mmax. So Mmax is at 2. What did we calculate? 245.625. Okay, so 245.625 times 10 to the power of 3 divided by 160 times 10 to the power of 6. Okay, so 245 160 power 6. So it's equal to 1.535 okay, 1.5352 times 10 to the power minus 3 meter cube, or 1.5352 times 10 to the power minus 6 millimeter cube. Why I changed to millimeter cube is over here is millimeter cube. And if I'm going to follow their expression over there is equal to 1535.2 times 10 to the power 3 millimeter cube. Okay. Now, some of you will ask me, Eugene, why didn't we use Mohs circle? Yes, it's a valid answer, right? Why this case we don't need to use Mohs circle, right? Now, this material property, the allowable is in tensor. Can anyone tell me why, right, by looking at the shear force and bending moment diagram, why we no need to use Mohs circle? Anyone? Interesting, isn't it? At this stage, at L2, we no need. Why? Anyone? I also wonder why before. This is because the shear stress is equal to what? 0, right? The normal stress is what? Maximum. If, okay, if we were to select point B or point C, then we have to use what? Mohs circle. Okay, you have to be really careful down here. So we have to. I'm not going to do it. Okay, relax. I have something else to teach you guys. We have to go back and then we have to plot Mohs circle again. We have to calculate the shear stress and then we can calculate. Okay, so based on bending moment. Okay, this is just based on bending moment. Okay, why just based on bending moment? Because the bending moment is at maximum shear force is at 0. If you pick elsewhere. Okay, I'm not saying that you cannot pick elsewhere. You can pick elsewhere. Okay, the results will be you have to combine with Mohs circle. Okay, so from here, I want to teach you how to select the beam. Okay, so we know that this has to be 1535. Okay, so anything greater than 1535 is good. So we go to the table. Okay, so 15. So anywhere from here onwards, these are all no good. Looking at the S value, okay? Looking at the S value, anything that's lesser than 1535, so over here, anything below is crap. You cannot use them. Anything below down here, you cannot use them. Okay? So what are the possibility? Okay? So the possibility is you cannot say pick as high as a value as you can. I know you can pick the highest value, but what is controlling is the cross-sectional area. So you have to focus on both the cross-sectional area. Now is where we do